On the morning of September 1st, 1939, as German tanks rolled across the Polish border, a different kind of warfare was being born in the skies above Europe. The engineers and test pilots gathered in secret facilities across Britain. Germany, the United States, and Japan knew that whoever controlled the fastest aircraft would control the heavens themselves. Speed wasn't merely an advantage in this coming conflict. It was survival, dominance, and the difference between returning home or becoming another name carved into a memorial wall. The question that obsessed military strategists and aviation designers alike seemed deceptively simple: which nation could build the fastest fighter aircraft? Yet this question would drive some of the most brilliant minds of the 20th century to push the boundaries of physics, metallurgy, and human endurance. The answer would be written not in textbooks, but in contrails across war-torn skies and in the desperate radio transmissions of pilots who suddenly found themselves outmatched by an enemy they couldn't catch or outrun. In the opening months of World War II, the Supermarine Spitfire captured the world's imagination as it dueled with the Messerschmitt Bf 109 over the English Channel during the Battle of Britain. These aircraft, capable of speeds approaching 350 miles per hour in level flight, represented the cutting edge of 1940 aviation technology. British pilots praised the Spitfire's maneuverability, while Luftwaffe aviators respected the Bf 109's climbing ability and dive speed. Yet both sides understood that these machines were merely the beginning of a technological arms race that would escalate with frightening rapidity. German engineers, working under the direction of Willy Messerschmitt and his team at the Bayerische Flugzeugwerk, pushed forward with increasingly powerful variants of their iconic fighter. The introduction of fuel injection systems gave German aircraft a crucial advantage in negative-G maneuvers, allowing them to dive away from pursuing Spitfires whose carbureted engines would momentarily cut out. This seemingly small technical detail saved countless German lives and demonstrated how incremental improvements in speed and performance could shift the balance of aerial combat. Across the Atlantic, American engineers watched the European air war with keen interest. Companies like Republic Aviation and North American Aviation began developing fighters that would incorporate lessons learned from the Battle of Britain. The United States Army Air Corps understood that American pilots would eventually need aircraft capable of escorting bombers deep into enemy territory missions that would require not just speed, but sustained high-speed performance at altitude. According to aviation historian Walter J. Boyne's comprehensive study, published in Air Force magazine, the American approach emphasized robust construction and powerful engines over the lighter, more agile designs favored by European manufacturers. Meanwhile, in the Soviet Union, design bureaus led by figures like Alexander Yakovlev and Semyon Lavokin worked frantically to develop fighters that could match German performance. The German invasion of June 22, 1941, known as Operation Barbarossa, caught Soviet aviation badly unprepared. Early Soviet fighters were outclassed by Luftwaffe aircraft, leading to catastrophic losses that nearly cost the Soviets air superiority over their own territory. By 1942, the nature of aerial combat had evolved dramatically from the dogfights over Britain just 2 years earlier. The Pacific theater introduced new challenges as American and Japanese forces clashed in the vast expanses between island chains. The Mitsubishi A6M0, known to Allied pilots simply as the Zero, had demonstrated that Japanese aviation technology was far more advanced than Western intelligence had assumed. With its exceptional range and maneuverability, the Zero dominated early Pacific air battles, shocking American pilots who had underestimated their opponent. Yet the Zero's supremacy exposed a fundamental truth about fighter design that would become increasingly apparent as the war progressed. The Japanese had achieved their remarkable performance by sacrificing pilot protection and structural strength. The Zero lacked armor plating and self-sealing fuel tanks, making it vulnerable to even modest battle damage. American pilots quickly learned that while they couldn't outturn a Zero, they could outdive it and use superior speed to dictate the terms of engagement. This tactical evolution using speed rather than maneuverability as the primary weapon would define the remainder of the air war. The introduction of the Republic P-47 Thunderbolt in 1943 marked a turning point in the speed race. This massive fighter, nicknamed the Jug by its pilots, weighed more than twice as much as a Zero, but could achieve speeds exceeding 430 miles per hour in level flight. Powered by the Pratt & Whitney R2800 double wasp radial engine with turbocharging, the Thunderbolt excelled at high altitude where its 2,000 horsepower could be fully utilized. The aircraft's rugged construction meant it could absorb tremendous punishment and still bring its pilot home a quality that saved countless American lives. German engineers responded to Allied advances with their own innovations. The Focke-Wulf FW-190, introduced in 1941, initially outperformed the Spitfire Mark V in nearly every category. British test pilot Captain Eric Brown, who flew captured German aircraft for the Royal Aircraft Establishment, later described the FW-190 as a beautiful machine to fly with outstanding speed and firepower. The appearance of this fighter over the Western Front caused serious concern among RAF commanders, who immediately prioritized development of improved Spitfire variants. The FW-190's BMW radial engine produced 1,700 horsepower at takeoff, giving the aircraft exceptional acceleration and climb rate. German ace pilots like Otto Kittel and Walter Novotny achieved remarkable success flying the Butcher Bird, as Allied pilots called it. However, the FW-190 shared the same vulnerability as all piston engine fighters of the era. It was approaching the practical limits of propeller-driven flight. Soviet aviation began closing the performance gap with German fighters through a combination of improved designs and better pilot training. The Yakovlev Yak-3, which entered service in 1944, proved to be an excellent low-altitude fighter. Soviet pilots appreciated its lightweight and responsive controls, which made it highly competitive against German fighters below 13,000 feet. Guards Lieutenant Colonel Pavel Golovachev reportedly stated that the Yak-3 was a weapon to match the best in the world. The British continued refining the Spitfire, producing increasingly powerful variants. The Spitfire Mark XIV, equipped with the Rolls-Royce Griffon 65 engine producing over 2,000 horsepower, could achieve speeds of 448 miles per hour. On August 27, 1939, just days before the war began, a revolutionary aircraft lifted off from Rostock-Marigny airfield in northern Germany. Test pilot Erich Warsitz advanced the throttle of the Heinkel He-178, and instead of a propeller roaring to life, a jet of burning gases erupted from the aircraft's tail. The world's first jet-powered flight lasted just 6 minutes, but in that brief span, aviation had crossed a threshold into a new era. Ernst Heinkel, the aircraft's designer, understood immediately that propellers had become obsolete. The future belonged to jet propulsion. The German Air Ministry initially showed little interest in Heinkel's jet experiments, dismissing them as impractical diversions from the urgent need for conventional fighters. This bureaucratic short-sightedness gave Britain's Frank Whittle, who had been developing jet engines since the early 1930s, time to advance his own designs. The Gloster E-2839, powered by Whittle's turbojet, flew for the first time on May 10, 1941. While faster than most contemporary fighters, the British jet program proceeded cautiously, treating jet technology as a post-war development rather than an immediate war-winning weapon. The Germans eventually recognized their mistake and threw resources behind jet fighter development. The Messerschmitt Me-262 Schwalbe, or Swallow, emerged as the world's first operational jet fighter. When test pilot Fritz Wendel first flew the aircraft on July 18, 1942, he achieved speeds that left propeller-driven fighters hopelessly outmatched. The Me-262 could reach 540 miles per hour in level flight, nearly 100 miles per hour faster than the best piston engine fighters. Adolf Galland, one of Germany's most successful fighter aces and general of the fighter arm, flew the Me-262 in May 1943. His report to Hermann Göring was emphatic. This aircraft opens up completely new tactical possibilities. Galland immediately recognized that the jet's speed advantage was so overwhelming that traditional dogfighting techniques became irrelevant. Me-262 pilots could choose when and where to engage, diving through bomber formations at speeds that made interception by escort fighters virtually impossible. However, the Me-262's development was hampered by Hitler's insistence that it be modified as a fast bomber rather than a pure fighter. According to aviation historian James S. Corum's detailed analysis in the Luftwaffe, creating the operational air war, this decision delayed the aircraft's operational deployment by nearly a year. When the Me-262 finally entered combat in July 1944, Allied bombers were already ranging across Germany with massive fighter escorts. The jet's revolutionary performance came with severe limitations. Its Junkers Jumo 004 engines were temperamental and had service lives measured in hours rather than hundreds of hours like piston engines. The aircraft required specially prepared concrete runways, making it vulnerable during takeoff and landing when Allied fighters would loiter near German jet bases. Fuel consumption was prodigious, and by late 1944, Germany's fuel supplies were critically depleted. Despite these challenges, the Me-262 proved devastatingly effective in the hands of experienced pilots. Major Walter Nowotny established the first operational jet fighter unit, Kommando Nowotny, in September 1944. The appearance of German jet fighters over European skies sent shockwaves through Allied air commands. American bomber crews, accustomed to fighting their way through flak and piston engine fighters, now faced an opponent that could close to firing range in seconds and disappear before escort fighters could respond. Intelligence reports from late 1944 painted an alarming picture. If Germany could mass-produce jet fighters and train enough pilots to fly them, the entire strategic bombing campaign might collapse. British intelligence officers interrogated captured Luftwaffe personnel and pieced together the extent of German jet development. The reports landed on the desk of Air Chief Marshal Sir Charles Portal, who immediately recognized that the Rav's Gloucester Meteor, Britain's answer to the Me-262, needed to enter service immediately. The Meteor had been flying since March 1943, but cautious development had delayed its operational deployment. Portal's intervention accelerated the program, and on July 27, 1944, the first Meteors arrived at RF Manston with 616 Squadron. The Gloucester Meteor Mark I, powered by two Rolls-Royce Welland turbojets, could achieve 410 miles per hour slower than the Me-262, but still faster than any piston engine fighter. The aircraft's twin-engine configuration provided redundancy and made it more reliable than its German counterpart. However, RAF commanders made a crucial decision that would frustrate Meteor pilots throughout the war. The jets were forbidden from flying over German-occupied territory. The Air Ministry feared that a crashed Meteor might provide German engineers with insights into British jet technology. This restriction meant that Meteors spent most of 1944 chasing German V-1 flying bombs over southern England rather than engaging enemy fighters. Flight Lieutenant T.D. Dean scored the Meteor's first victory on August 4, 1944, when he tipped a V-1's wing with his own wingtip, sending the flying bomb crashing into a field. It was an inglorious combat debut for an aircraft designed to dominate the skies, but it demonstrated the Meteor's speed advantage even over the pulse jet-powered cruise missiles. Across the Atlantic, American aircraft manufacturers raced to develop their own jet fighters. The Bell Pa-59 Aerocomet, America's first jet aircraft, flew on October 1, 1942. However, the aircraft's performance disappointed Army Air Force's evaluators. With a top speed of only 430 miles per hour and sluggish acceleration, the Pa-59 was barely faster than the best piston engine fighters and inferior in other performance categories. The aircraft never saw combat, serving instead as a jet training platform for American pilots transitioning to jet-powered flight. Lockheed's design team, led by the legendary Clarence Kelly Johnson, produced a far more successful design. The Piety Shooting Star, which flew for the first time on January 8, 1944, achieved 525 miles per hour in level flight faster than the Me-262. The P-80's single General Electric I-40 turbojet was based on the British Whittle engine design, demonstrating the value of Anglo-American cooperation in jet technology development. The first P-80s arrived in Italy in late 1944. Assigned to the 51st Fighter Group, American pilots eagerly anticipated combat against German jets, but the war ended before any jet versus jet encounters occurred over Europe. The question of whether the P-80 could have defeated the Me-262 in combat remains one of aviation history's great unanswered questions. While jets represented the future, the final years of World War II saw piston-engine fighters reach their absolute pinnacle of performance. Engineers extracted every possible increment of speed from propeller-driven designs, creating aircraft that pushed right to the edge of physics itself. These machines represented the final evolution of a technology that had carried humanity from the Wright brothers' first flights at Kitty Hawk to the threshold of supersonic flight in just 4 decades. The North American P-51 Mustang emerged as perhaps the most successful fighter of the entire war, and certainly the most important for the Allied victory in Europe. The aircraft's development began with a British Purchasing Commission's request in 1940 for a fighter that could be produced quickly using American industrial methods. North American Aviation's design team, led by Raymond Rice and Edgar Schmude, produced the prototype in just 117 days, a remarkable achievement that spoke to American engineering prowess and manufacturing efficiency. The early Mustangs, powered by Allison engines, showed promise but lacked high-altitude performance. Everything changed when British test pilots suggested mating the Mustang airframe with the Rolls-Royce Merlin engine. The resulting P-51B, which entered service in December 1943, transformed the aircraft into a world beater. At 25,000 feet, the Merlin-powered Mustang could achieve 440 miles per hour, and its laminar flow wing design gave it exceptional range over 1,600 miles with drop tanks. This range proved decisive in the air war over Germany. For the first time, American heavy bombers flying deep penetration raids to targets like Berlin, Schweinfurt, and Regensburg could have fighter escort for the entire mission. Luftwaffe fighters, which had previously attacked bombers with relative impunity once they crossed beyond the range of 47 escorts, now faced Mustangs throughout German airspace. The impact on bomber losses was immediate and dramatic. Lieutenant Colonel John C. Meyer, who commanded the 352nd Fighter Group, later wrote that the P-51 gave American pilots the freedom to take the fight to the enemy on his own territory. Meyer himself shot down 24 German aircraft while flying Mustangs, making him one of the war's top aces. The combination of speed, range, and maneuverability made the Mustang the complete fighter capable of both escorting bombers and engaging enemy fighters on equal or better terms. The Germans responded with increasingly desperate measures to maintain air superiority over the Reich. The Focke-Wulf Ta-152, which entered limited service in January 1945, represented the ultimate development of Kurt Tank's radial engine fighter series. Powered by a Junkers Jumo 213 engine producing over 2,100 horsepower and featuring a longer wingspan for better high-altitude performance, the Ta-152 could achieve 463 miles per hour at 34,000 feet. German test pilots praised the Ta-152's performance, with some claiming it was superior to the Lear-190D9 in every category. As 1945 began, the air war over Europe reached a crescendo of technological desperation and innovation. German aircraft designers working in factories threatened by Allied bombing and Soviet advance pursued increasingly radical concepts in a race against time and history. The question of who possessed the fastest fighter had evolved from a matter of tactical advantage to one of national survival for the Third Reich. Every additional mile per hour might translate to a few more bombers shot down, a few more days of resistance, a slight chance of forcing the Allies to negotiate rather than demand unconditional surrender. The Messerschmitt Me-263 Comet represented the most extreme attempt to achieve absolute speed supremacy. This rocket-powered interceptor, which first flew operationally in May 1944, could reach 596 miles per hour in level flight, making it the fastest aircraft to see combat during the war. Pilots who flew the Comet described the experience as unlike anything else in aviation. The aircraft accelerated so rapidly that it pinned them to their seats, climbed nearly vertically, and reached bomber altitudes in under 3 minutes. However, the Comet's revolutionary performance came at a catastrophic price. The aircraft's Walter HWK-500 Nano rocket motor burned a highly volatile fuel mixture of Seestoff and T-Stoff substances so reactive that any contamination or spill could cause explosions. Several pilots died not from combat but from fuel system failures that dissolved their aircraft around them in mid-flight. The powered flight duration was barely 8 minutes, after which the Comet became a glider that had to land on a skid, leaving the pilot vulnerable during approach and landing. Oberleutnant Fritz Kelp of Jagdgeschwader 400 achieved the first confirmed Comet victory on August 16, 1944, shooting down a Boeing B-17 Flying Fortress. Yet despite their astonishing speed, Comets accounted for only 9 confirmed Allied aircraft destroyed during the entire war. The closure rate was so high that pilots had less than 2 seconds to aim and fire, and the aircraft's limited endurance meant that even minor complications during takeoff or climb could abort the entire mission. British test pilot Captain Eric Brown, who flew a captured Comet after the war, later described it as the most dangerous aircraft I ever flew. Brown noted that while the speed was intoxicating, the aircraft was fundamentally unsuited to combat operations due to its brief powered flight time and hazardous fuel system. The Comet represented the logical extreme of prioritizing speed above all other considerations, a dead-end, evolutionary branch in fighter development. Meanwhile, more practical developments continued in piston engine technology. The Supermarine Spitfire reached its ultimate evolution with the Mark 24, which entered service in April 1945. This final variant, powered by the Rolls-Royce Griffon 61 engine producing 2,375 horsepower, could achieve 454 miles per hour at 26,000 feet. The aircraft bore little resemblance to the graceful Spitfire Mark Is that had defended Britain 5 years earlier. It was heavier, more powerful, and optimized for speed rather than the turning performance that had made earlier Marks so beloved by pilots. The Soviet Union's final wartime fighter contribution came with the Lavokin La-7, which entered service in early 1945. This development of the La-5 featured a more powerful Shvetsov Ash-82FN engine and refined aerodynamics that enabled speeds of 423 miles per hour at 20,000 feet. While European skies witnessed the clash of jets and rocket planes, the Pacific theater presented unique challenges that demanded different solutions to the speed question. The vast distances between island bases and the need to escort bombers across hundreds of miles of ocean meant that range often mattered more than raw speed. Yet, as the Allied advance brought American forces closer to the Japanese home islands, the speed race took on new urgency as both sides developed fighters optimized for high-altitude interception and bomber escort. The Grumman F-6F Hellcat, which entered service in January 1943, transformed the naval air war in the Pacific. While not the fastest carrier fighter, its top speed of 380 miles per hour was modest compared to late-war European fighters. The Hellcat possessed the right combination of performance, durability, and ease of handling to give American naval aviators a decisive advantage over Japanese opponents. Commander David McCampbell, the Navy's top ace with 34 confirmed victories, achieved all his kills while flying the Hellcat and praised the aircraft's stability as a gun platform. The Japanese responded to the Hellcat threat with increasingly capable fighters. The Kawanishi N-1 KJ Shidenkai, known to American pilots by the reporting name George, entered service in 1944 and proved to be one of Japan's finest fighters. Captain Frederick Trapnell, the U.S. Navy's senior test pilot, flew a captured Shidenkai and reported that it was the most formidable Japanese fighter encountered in the Pacific War. With a top speed of 369 miles per hour and excellent maneuverability at all altitudes, the Shidenkai could engage Hellcats on relatively equal terms. However, Japan's industrial base, increasingly strangled by submarine warfare and strategic bombing, could not produce enough Shidenkais to influence the war's outcome. Manufacturing quality deteriorated steadily throughout 1944 and 1945, with engines failing prematurely and airframe components that didn't meet specifications. Even when Japanese pilots had superior aircraft, they often couldn't maintain them properly or obtain replacement parts when components failed. The Republic P-47 Thunderbolt, which had proven so successful in Europe, also served with distinction in the Pacific. The Thunderbolt's rugged construction made it ideal for ground attack missions, and its excellent dive speed allowed pilots to escape trouble when confronted by Japanese fighters at lower altitudes. The 5th Air Force in the Southwest Pacific became the Thunderbolt's primary user, with aces like Colonel Neil Kirby and Major Gerald Johnson achieving remarkable success in the aircraft. North American's P-51 Mustang arrived in the Pacific in late 1944, and its exceptional range made it invaluable for the strategic bombing campaign against Japan. When Boeing B-29 Superfortresses began operating from the Mariana Islands in late 1944, they initially flew unescorted missions to Japan, a distance of over 3,000 miles round trip. Losses to Japanese fighters and operational accidents were substantial until Mustangs began providing escort in March 1945. The Iwo Jima campaign, fought from February to March 1945 at tremendous cost in American casualties, was justified primarily by the need for an emergency landing field for damaged B-29s and a forward base for Mustang escorts. Colonel James H. Howard, who had achieved ace status in China while flying with the Flying Tigers, transitioned to Mustangs and continued his success in the Pacific. As spring turned to summer in 1945, the question that had driven aviation innovation throughout the war approached its resolution. The fastest operational fighters represented the absolute pinnacle of two distinct technological paths: the refinement of piston-engine aircraft to their physical limits, and the revolutionary leap to jet propulsion that promised to render everything that came before obsolete. Yet determining which aircraft truly deserved the crown as history's fastest World War II fighter required looking beyond simple top-speed figures to understand the complex interplay of altitude performance, acceleration, dive speed, and combat effectiveness. The Messerschmitt Me 262, despite its operational limitations and the chaos of Germany's collapse, achieved the highest sustained level flight speed of any fighter to see combat during the war. Test pilots pushed specially prepared examples to 560 miles per hour at 20,000 feet, and pilots regularly reported speeds exceeding 540 miles per hour in operational missions. No piston-engine fighter could approach this performance, and even the Gloster Meteor fell short by substantial margins. However, pure speed tells only part of the story. The Me-262's brief engine life, vulnerability during takeoff and landing, and the scarcity of trained pilots limited its impact on the war's outcome. According to post-war assessments by Allied intelligence, German jet fighters destroyed approximately 750 Allied aircraft, a respectable but not overwhelming total given the thousands of conventional fighters shot down by piston-engine aircraft throughout the war. The North American P-51 Mustang, with a top speed of approximately 440 miles per hour depending on variant and altitude, was significantly slower than the Me-262. Yet the Mustang's combination of speed, range, maneuverability, and reliability made it arguably the most effective fighter of the war. Over 15,000 Mustangs were built, and they served with distinction in every theater. The aircraft remained in service with various air forces well into the 1980s, demonstrating a versatility and practicality that jet fighters took years to match. In the Pacific, the question of speed supremacy ended not with aerial combat but with nuclear fire. On August 6, 1945, Colonel Paul Tebbets piloted the Boeing B-29 Enola Gay to Hiroshima, escorted by two other B-29s but no fighters. The atomic bomb dropped that day, and the second weapon delivered to Nagasaki 3 days later rendered debates about fighter performance suddenly academic. Japan surrendered on August 15, 1945, ending 6 years of conflict that had transformed aviation from an extension of cavalry reconnaissance to a war-winning strategic weapon. Captain Eric Brown, who systematically flew captured German, Italian, and Japanese aircraft for the Royal Aircraft Establishment after the war, concluded that the May 262 was indeed the fastest fighter of World War II. However, Brown noted in his comprehensive analysis that speed alone does not make a successful fighter. The Mustang's balance of characteristics made it the superior weapon despite its lower top speed, while the FW-190D9 represented the ultimate evolution of piston-engine fighter design. The legacy of World War II's speed race extended far beyond 1945. The jet engines, swept wings, and high-altitude performance developed during the conflict formed the foundation for Cold War aviation. Within 5 years, fighters would routinely exceed the speed of sound, a barrier that seemed impossibly distant when war began in September 1939. So who was the king of speed? The answer depends on how one measures royalty. If pure velocity determined the crown, the May 262 wore it undisputedly. If effectiveness and impact mattered more, the Mustang deserved recognition. Perhaps the truest answer is that the king of speed was the relentless human drive to innovate, improve, and push beyond perceived limitations, a quality that defined both the terrible destructiveness and the remarkable technological achievement of humanity's most devastating conflict.